CircuitPython students, powerful Pythonistas, and magnificent makers, it's Prof G here to show you how to set up the PyCharm Python editor to work with CircuitPython and your microcontrollers. Now this will take a little bit of initial setup work, but once you do this, I think you'll find that PyCharm is super helpful with better code completion and error reporting that make it easier for you to catch the sort of simple mistakes that often trip up folks that are new to CircuitPython coding. Now to follow along with this video, I'm going to assume that you already have a microcontroller configured with the latest version of CircuitPython. This is not the best video for absolute beginners. If you're new and you need to set up your board, you should probably start with the first video in this YouTube playlist. Now my students use the Circuit Playground Bluefruit or CPB as well as the Raspberry Pi Pico W in their course, so I'll show you how to set things up with these two boards, but if you have another board, the setup should be pretty much the same, and I'll point out where things might be different. And remember, if you run into any difficulty, you can always ask for help via the kind folks on the Adafruit Discord channel. That's where I went to figure out how to set all this up. Now this will take a little bit of initial setup work, but once you do this, I think you'll find that PyCharm is super helpful. I think that PyCharm is a good choice for most college and high school students, and if you have more advanced middle schoolers, they might be able to use it too. So here's what we'll do. We'll make sure that our Macs have the latest version of Python. We'll download and install PyCharm CE. That's the free version of PyCharm. We'll create our first PyCharm project. We'll set the project up so that it saves our program to the CircuitPy board, not our computer. Remember, we want our programs to run on the board, not our Mac or PC. We'll configure our project so that it recognizes extensions in the CircuitPython programming language, so that's stuff beyond basic Python, and we'll do this by adding something called the CircuitPython-stubs to our project. We'll also show you how you can add new libraries to your project so that these might be recognized as well, and we'll make sure that our project knows which microcontroller or board we're using. Now, one issue that we're going to run into with PyCharm is that it doesn't have a serial console like Mu, so PyCharm won't show us the results of code running on our CircuitPy boards. But we'll go through the setup of installing a program called TIO. That'll let us use a terminal program like Mac Terminal that comes with all Macs, so it can act just like the Mu serial console. It'll even work like a REPL. So there are a few steps in there, but once we do this, most of this work won't need to be repeated. So on with the setup. First, let's make sure that our Macs have the latest version of the Python programming language. Open a browser and enter the URL python.org. Click the download link. It knows I'm using Mac OS, so I'll click the Python button with the latest version. My Mac is configured to ask me where I want to save. I'll save the download to the desktop. Yours is probably saving to the download folder. So minimize your browser, go into your download folder if you need to. I can see the file that I downloaded is named Python, the version number, Mac OS, and .pkg. Double-click that to run the installer, follow the prompts to continue and agree to the user agreement, click Install, enter your Mac's password if asked, and click Install Software. After a few moments, Python will be installed on your Mac. If I two-finger click on the name that shows up in the Finder window that pops up, I can see that Python is installed in my application folder. Nice! You can close the Finder window and the installer program and drag the installer into the trash. Now friends, let us download and install the PyCharm program. So you can open up your browser, search for the key term PyCharm, P-Y-C-H-A-R-M, and you should see the first link that shows up is a link to the JetBeans website, so click that. Click the download button. Now the first option that shows up is for PyCharm Professional. That's the paid version, and we don't want that, so keep scrolling until you find PyCharm CE. That's the free version. That's going to be great for us. But don't click it yet. This button knows that I have a Mac, but very important point, it says Intel next to .dmg. Hey, I don't have an Intel Mac. If you're wondering what kind of Mac you have, meaning what kind of processor is inside, you can head up to the Apple menu, select About This Mac, and if the chip says Apple, then the chip starts with the letter M. You don't have an Intel Mac, you've got an Apple Silicon chip inside. If that's the case, pull down this drop-down and select .dmg Apple Silicon. Again, your download is probably going to go directly to your downloads folder. My browser's configured to ask me where to save this. I'm going to save mine to the desktop. When your download is done, you can minimize your browser, head to your downloads folder if you need to, then double-click the pycharm.pkg file that you just downloaded, drag the PyCharm CE icon into the Applications folder. If you open your Applications folder now, you should find PyCharm is in there. Now, I also like to put PyCharm in my dock so it's nice and handy, so I'm going to drag the PyCharm icon into the dock and let it go, placing it right next to my other IDEs. And you can minimize the install window, and you can drag both the .pkg file and this PyCharm CE gray installer icon into the trash, and the installation is done. Now before we create our first PyCharm project, let's make sure that our board is plugged in. So here's my CPB. I've got one end plugged into the Mac. I'm going to plug in the other end here. Always make sure that you're using a data cable, not a charge-only cable, or things won't work. Now let's launch PyCharm. Mine is in the dock. The first time you run this, you might be asked if you want to open something that you downloaded from the internet. Yes, you do. So press open, and you see the Welcome to PyCharm window. PyCharm will show your recent work if you have any. We have no projects in PyCharm, so just click the New Project button, and we'll see the New Project Setup screen. Now, unfortunately, this doesn't show you the friendly Finder navigation menu that you usually see if you select a folder to save a file and give it a file name, but this window is doing the same thing that you would see, for example, if you selected Save As on a Mac. Now, the first thing we want to do is to select the folder where we want to save our project. So on this line here that says Location, click this little folder icon off to the right, and we can navigate to wherever we want to save our project. I want to save mine to the desktop, but in a new folder. So I'm already on the desktop. You can navigate there if you want to. And I'm going to click on the new folder icon on the lower left. I'll give my folder a name. How about PyCharm Projects? Click Create. I see the PyCharm Projects folder is on my desktop. Click Open. And then we return to the prior window, but we can see the location line has the path for that new folder that we just created. Now let's give the project a file name. Since I'm working on the Circuit Playground Bluefruit, I'm going to call my file cpb-circuitpython. Feel free to use whatever name you'd like, and then click on Create, and ho-ho, our project is open. I like to take up the maximum amount of screen real estate, so on the Mac, if you find an empty spot in the window title bar, you can double-click and your window will take up the whole screen. I prefer to do this instead of clicking on the maximize button because I like to see the menus. By the way, I think this column's too big, so I can move my mouse on top of the separator line and click and drag to shrink it. Now next we're going to get into our project settings and do three things. We're going to make sure that autosave is not on. That'll prevent the code from the CPB running each time the autosave happens, which would otherwise be all the time. And we're also going to select the version of Python to use, and we'll make sure that we save our files to our CircuitPy volume. Now all of this is done under the Settings menu item, which on the Mac is under the PyCharm menu. Under Windows, it's under the File menu. Select Settings, and let's make sure that System Settings is selected on the left-hand side. And remember, if you don't see it, these little greater than symbols are exposure triangles. Click them, they point downward, and they show everything that's inside that menu item. So System Settings is underneath Appearance and Behavior. My project already has checkboxes empty for save files if the IDE is idle, and save files when switching to a different program. We want both of these checks to be empty or unchecked, so make sure that that's what you're seeing in your settings as well. Otherwise, uncheck those two boxes. We also want to make sure that we have the settings so that we get a visual indicator when we have unsaved changes in our code. So I'll click next to Appearance and Behavior to shrink this up, and then select Editor that's underneath that. Then under Editor, select General and Editor tabs, and select or check the box that says Mark Modified. Then we're going to open the settings for our project. Now you see the line down here that says project:/CPB-CircuitPython. Now this is the same name that I gave my project. We can see it in the top folder in the window behind this one. So let's click on project: and the project's name, and we see two options in here: Project Structure and Project Interpreter. Let's click Project Interpreter. This is where we select the version of Python to use. Now, in this Python Interpreter menu, there's a chance that yours is already selected, but it's okay if you repeat this step. Pull down this menu and select the highest version of Python that you see in here. For me, that's Python 3.12. And now under Package, it just says pip, but we'll change this in a minute. But now let's click on the project structure under the project settings on the left-hand side. And this is where we set up our project so that it saves files to the CircuitPy volume. That means our board that's plugged into our computer. So to do this, we want to click on this little plus icon next to the folder and the path name. And when this window opens up, we want to find the name of the CircuitPy volume. On the Mac, you can do this in the left-hand column. You might have to scroll to find it, but click on CircuitPy. This should show all the files that are inside your board. You might have different files if you've been working on new projects, but either way, click on Open, and we've now configured this project to save files to the CircuitPy volume, which means save the files to our board. Cool. Now, in fact, if we click OK, we see the leftmost column has the project name. Click the expansion triangle so that it points downward, and we can see a second folder named CircuitPy. That's our board. So if we click that expansion triangle, we see the files that are on that board. Now, one tricky thing is this shows some invisible files that are on your board. They're hidden. So if you look on your board and you don't see files with names like FS events, metadata, trash, or anything that starts with an underscore, don't worry. They're just hidden files. You can ignore them. But if we head to the Finder and we take a look at our CircuitPy volume, we do see that there's a file boot_out.txt, code.py, which is a really important one, that's our code, and our lib folder. Now all of these are listed under the CircuitPy folder heading in the left-hand column of our project in PyCharm. Cool. Now I happen to be using a new CPB with nothing in the lib folder, so that's why I don't show a little expansion triangle next to lib. If you've got lib files, they'll be in here. But Python coders, what we really want to do is check out the code.py file. Remember, that's the code that executes on our board. So let's double click on that bad boy and oh, look at that. We see our code in PyCharm. Nice. Now for me, this is just the basic hello world code that comes on new boards. It's just a single line. If you've been working on projects, you're likely seeing all of the last code that you wrote right here. Now, if you want to keep that code, make sure that you make a backup of your code.py file now. You'll want to do that because we're about to change this code. Now what we're going to do is find some sample code and paste this over the existing code. This will be code that simply blinks any CircuitPython board with a built-in LED light. Now both boards my students use have supported LED lights on them, so let's open a browser. We'll enter the following URL, bit.ly/cp for CircuitPython -blink, all one word, all lowercase, and a GitHub page opens up with some sample code. Select all of the lines of this code, and with the code highlighted, press Command-C on a Mac to copy, Control-C for Windows. Then let's head back to PyCharm and we'll select the code that's there. And before we paste over this code, notice that I didn't make any changes to the code that I just loaded up. So the code.py tab that you see up here just says code.py. But look what happens when I highlight the code. Look at that tab. I'm going to press Command-V or Control-V in Windows to paste that code over. And now the code.py tab has a little blue dot next to it. That little blue dot is an unsaved changes indicator. It's a handy way to know if you haven't saved your work. And then we see the new code shows up. It's nicely formatted by PyCharm. Cool. Now, one of the things that PyCharm does that's wonderful is it will put squiggly red underlines underneath anything that it sees as an error. And if I hover my cursor over this squiggly line under the word board, PyCharm pops up a little box that says no module named board. And if we do the same thing for digital I/O, PyCharm says no module named digital I/O. Now, both of these are built into CircuitPython. But remember, when we set up our Python interpreter, we use the regular Python, but what we didn't do is we didn't add any extensions that extend Python so that it can be CircuitPython. Now, to get the very basics of CircuitPython into our project, we need to go back into the interpreter and add what are called the CircuitPython-stubs. To do this, we open up our settings. On the Mac, it's under the PyCharm menu. Under Windows, it's under the File menu. And now under Settings, find our project on the left-hand side, select Python Interpreter, and find this little plus icon that's above the Packages line. Click it, and in the search box up top, we're going to type in the name of any packages or extensions to Python that we want to use. Now, we specifically want to use the CircuitPython-stubs so that this project knows about the basics of CircuitPython. So simply type in CircuitPython-stubs, all lowercase, all one word. When you press return, you should see CircuitPython-stubs shows up. Click that line, click Install Package, click Close, click OK, and oh, gadzooks, my friends, those two red squiggly error lines went away. That's because our project now knows about the basic CircuitPython extensions. It knows that every board should know that it can import board, and it can import digital I/O, so these no longer give you an error. Very cool. Now, even though we've added CircuitPython-stubs, this only lets PyCharm recognize the basics built into CircuitPython. But there are plenty of extra CircuitPython libraries that you might want to add later on that aren't part of CircuitPython and that aren't part of the CircuitPython-stubs. For example, let's assume we want to work with neopixels in our code. Well, from earlier lessons, you know that we add this to our import line. We say comma neopixel singular, and look at this. PyCharm puts a red wavy line underneath neopixel. That's because PyCharm, not your board, but PyCharm, doesn't know about the NeoPixel library. So to solve this issue, every time we use PyCharm with a library that's in our lib folder on our board, we also want to add the package to our project. Now the steps are identical to what we just did with the stubs. We just search for a different name. So we're going to open our settings back up. Under our project name, click on Project Interpreter. By the way, notice that this list shows circuitpython-stubs that we just added previously. Another thing to note, when we add support for the NeoPixel library, this is actually a much more complex package that requires additional modules as well. So after we add NeoPixels, close this window, then return here and open this back up, you'll see a lot more stuff than just the NeoPixel module that you added. Don't worry, those are supposed to be here. By the way, the terms get a little bit confusing. So a library is pre-written code that will extend your language. For example, the NeoPixel library can extend the CircuitPython language so it's got statements so that it can work with NeoPixels. Oftentimes developers will use the term library and module interchangeably. The difference really isn't important for this stage in our Python journey. Now, a package might include one or more modules, and that's what's going to happen when we install NeoPixels. So PyCharm's automatically going to add a bunch of other stuff that it will also need so that it can recognize and use NeoPixels. So to add support for NeoPixels, we're going to do the same thing we did with CircuitPython-stubs. We're going to click on the plus sign here. But here, my friends, is a key pro tip you need to remember. This is actually really important and can trip up even more experienced users. To use PyCharm to find and install an official Adafruit CircuitPython package, search for a package with a modified version of the name that you would find in the lib folder, but with an Adafruit-CircuitPython- prefix. For example, to find and install a package for the NeoPixel library, see it's got nothing out front here, no prefix. In PyCharm, you want to search for the name Adafruit-CircuitPython-NeoPixel. As another example, in a future lesson, we're going to use a distance sensor called the VL53L0X, and that's in the Adafruit lib folder as Adafruit_VL53L0X. If you were going to add the package for that, you'd want to search for Adafruit- not underscore CircuitPython-VL53L0X. Also, make sure you're using dashes when you search for things in PyCharm. Those same names usually have underscores in the library. Now, just to show you, this can be tricky if you forget. If you want to install the package in PyCharm for the NeoPixel library, it's named NeoPixel in the lib folder, but if I search for just NeoPixel in the PyCharm box, I do see a package named NeoPixel, and this is not what we want. We want to search for Adafruit-CircuitPython-NeoPixel, all one word, all lowercase, dashes, and not underscores. So remember, when you search in this box, always make sure you're prefixing with Adafruit-CircuitPython- and then a library name. So we found Adafruit-CircuitPython-NeoPixel in the list. That's what we want. Click it. Click Install Package, click Close. So these are the packages we installed previously. Now, sometimes this behavior looks a little inconsistent, but don't worry. I'm currently showing all of the packages that were installed along with Adafruit CircuitPython-NeoPixel. Sometimes all of them don't show, but if not, we can just click OK, then go back into Settings, then go back into Projects Interpreter, and we should see all of the additional files that were installed along with that NeoPixel package. Good. So let's click OK, and look at that. The red squigglies have gone away. Now PyCharm knows about the NeoPixel library. This also means that code completion can provide suggestions about all of the NeoPixel library's functions and data structures. We also see PyCharm has grayed out the box around the word NeoPixel. That's because this library is currently not used in any of the code below it. Now, this is a nice touch because if you look at completed code, you might see that some of the libraries that you've imported are grayed out. If that's the case, you can eliminate those import statements from your code. And if you've still got any of those libraries in your lib folder on your board, you can get rid of those too if you need the space, but you don't have to. Now, there's one other thing that we're getting squigglies with over here. That's these yellow squigglies that are underneath .led. If I hover my cursor over that, PyCharm says, can't find reference LED. This means that PyCharm doesn't know about this dot notation LED that's available via the board object. How come? Well, some boards have LED lights and some don't. The LED light is here on the CPB, it's here on the Raspberry Pi Pico and Pico W that we also use in this course, but some boards don't have that light. If that's the case, the board object won't allow you to say .led. But I'm using a Circuit Playground Bluefruit, so I should be able to use that. Now, the board library and its capabilities vary depending on which board is used, and the way that we can tell PyCharm which board we're using is to open up the local terminal, terminal. That's this icon on the left-hand side. It looks like a little square with a chevron or greater than symbol inside of it. Click that, the terminal opens up, and here we just enter the command circuitpython_setBoard space. It's really important that you make sure that you're using the underscore in here. It's really easy when sometimes you're using dashes and underscores to get those mixed up. Then after the space, we enter the name of the board. So since I'm using the Circuit Playground Bluefruit, I'm going to enter Circuit Playground_Bluefruit. When I press enter, we see a message that says the setting has been made, and most importantly, the LED with the warning squigglies goes away. Excellent. Now, if you're using a different board, my students also use the Raspberry Pi Pico W, so the name of that board is Raspberry_Pi_Pico_W. If it's just the Raspberry Pi Pico, there's not an _W at the end. The Circuit Playground Express is just Circuit Playground_Express. Now, if you have a different board and you want to know the name, there's a soon-to-be-released modification that you may already be able to use. To list all the available boards in the terminal, after the prompt, you should be able to enter CircuitPython_setBoard and then space -L for list. And if you press return there, you'll receive hundreds of boards that you can scroll through. You might want to hunt for boards that just have a particular string in the name, like Raspberry. And to do that, you simply add space Raspberry after this command. Again, the revision has been made. It just hasn't been pushed out yet. So at the time I recorded this, I'm not able to demonstrate it. But take a look for it, and if for some reason you still can't find the board's name, ask on Adafruit's Discord. So now I can close the PyCharm terminal window by clicking on this horizontal line, and just to show you the LED is recognized via code completion, if I backspace over board.led here and then type in board. I see all these additional items are recommended. These are the things that I can access on my CPB board. These include buttons A and button B, the audio object, the accelerometer. These wouldn't show on many of the other boards, but they're built into the CPB, and now my PyCharm project knows I'm using a CPB, so it provides the recommendations in code completion. Now, since LED is highlighted, I can just press return, and LED is entered for me. Dynamite! Now, before we run our code, there's another thing that we should do. If you've ever used Mu, you know there's an area in Mu called the serial console that's linked to your board, and it shows the output of code.py executing on your board. It can also report any errors in your code execution, and it can act as a REPL. Now, while PyCharm has a console, it doesn't connect to any of the boards that are attached to the computer. It only shows the result of code that would run on the Mac. Now, even though we can't use the PyCharm console, we can do the next best thing. We can use the terminal program to install another program called TIO, and then open the terminal and run TIO whenever we have PyCharm open running code on our CircuitPy board. TIO is then going to act like a serial console. It will show any output from the board, it'll show errors that occur when the code's running, and it can also be used as a REPL. So let's install TIO and see how to use it. Now I'll use Mac Spotlight to run the terminal program. To do this, just press Command Spacebar, then enter the word terminal, press return, and the terminal launches. It's very ugly, it's all text, but it's what we need to run TIO and show our board's output. And actually, we have a few steps to go through. First, need to install a program called Homebrew or Brew, which is a program that installs other programs in the terminal. Then we can install TIO, and then I can show you how we run TIO in the terminal. So first, to install Brew or Homebrew, that's the terminal installer program, we want to open a browser and go to the very unusual URL, brew.sh. There's no .com in there. And you'll see this big line under Install Homebrew. We can copy this entire line here. So this is the command we want to enter in the terminal. Just click on the little clipboard icon to the right of the line, and then I'll Command Tab over to get back to the terminal program. I'll press Command V to paste in what I just copied, press return. You might be asked to enter your Mac's password. You won't see anything as you type. Press return when you've entered it. You want to make sure you enter it properly. I got mine wrong. Then just follow any prompts that show up on screen. So you might be asked to press return again at different times during the installation process. Sometimes it might look like things have stalled. Don't worry, it's probably fine. Sometimes it just takes a little bit of time to show any work that it's doing. Pay attention to see if there are any prompts in there. My installation took about 4 minutes. And when you're done, you should be back at the %sign prompt. Our install is looking good. Now that we've installed Brew, we're going to use Brew in the terminal to install TIO, and we do that by using the command brew space install space TIO, that's spelled TIO for terminal IO, like uncle in Spanish, and press return. And my installation took a little over a minute, and when you're done, you should be back at the %sign prompt. And you can minimize your browser for now. And now let's see how to use TIO. Actually, first, why don't we verify that TIO was installed? I can just enter this command at the %sign prompt, to space dash dash version and press return, and I see that TO version 3.3 was installed. You might have a later number. If so, that's totally fine. Then to use TO, we first need to identify how our computer refers to the CircuitPython board that's plugged into our computer. So your board should be plugged into one of your USB ports right now. Then at the %sign prompt, we're going to enter ls. This is a command that's going to list out files and directories, space, then, as all one word, /dev/tty dot in the asterisk character. Press return. You should see a list of various things that are connected to your computer. You want to look for one that says USB modem. That's this one here, tty.usb modem, and a number after it. Your number might be different, but what we want to do now is to highlight this whole line with the USB modem, starting from /dev all the way through the last character in that USB modem name here. With this whole line highlighted, I'm going to Command-C to copy this to my clipboard. And so sorry, I don't mean to overload you with too many options, but if it's easy to remember, you can also type in TO-L or TO-list. This shows a very long list, but in this list, you should be able to find toward the end one listing with tty.usb modem, and you can select it. It's the same result that we want. Then at the % prompt, I'm going to enter TO, space, I'll press Command-V. That'll enter the whole name that I just copied. Press return, and ho-ho, we see some output, including a line that says we're connected to the USB modem, which isn't a very friendly name, but that means it's connected to your CircuitPy board. Nice. Now let's try it out. So we'll head back into PyCharm and save our work. Now back in PyCharm, another thing you might wonder about is why do we have more squiggly yellow underlines in here? Well, these are warnings. They're not errors. They're not in red. It doesn't indicate that our code is going to crash. PyCharm just doesn't like the way that the code was formatted that we just pasted in. It wants to indent these a little bit more. If I hold my cursor over one of the yellow squiggly lines, I can see a link to reformat the file. I'll click that. PyCharm updates the indents to the fuzzy distance that it prefers, and the yellow lines go away. Before we save and run the code, I suppose we should talk about what the code does first. So it's going to print out this line that says CircuitPython on PyCharm is awesome. We'll see that in the serial console. We'll see it in TO. And then these two lines down here simply set up the LED light object. So that isn't the NeoPixel lights that are any color. The LED is just a single color. And that's going to be set up on the board. And I can refer to this by this name here, lowercase LED. It's set up to be an output. That's what a light is. We're not reading anything or input from this. It's just output. And then in my while true loop, which runs forever, LED.value equals true. We'll turn the light on. Time sleep 0.5 waits half a second. Then LED value equals false. We'll turn the light off. I also wait another half second, and then I repeat over and over again because I'm in a while true loop. So in order to save this, to get this to execute, we use a familiar keyboard shortcut that you probably know. It's Command-S on the Mac, Control-S on Windows. After saving, the blue unsaved changes indicator goes away. I'm going to Command-Tab to look at the output of my executing code in TO, and gack! Oh, I see that I have an error in my code. It says input error, no module named NeoPixel. Now, you might not have this error at all, but I do. The problem is I'm using a brand new CPB. It has an lib folder in there, but I didn't copy over the NeoPixel file in my lib folder. If you went through the prior setup instructions for your CPB, you probably have the NeoPixel in here, so you probably didn't get this error. I'll add the NeoPixel file later, but for now I'm just going to return to PyCharm. And remember, NeoPixel is grayed out because I'm not actually using that library, so I can delete NeoPixel and the comma. I'm going to Command-S to save again, Command-Tab to get back to the terminal. And now I see my code run. It usually takes a second or two to see results. CircuitPython on PyCharm is awesome. And even cooler, if you look down at your board, you should see this little LED light flashing on your CPB. And if you're using a Raspberry Pi Pico W, this is what it looks like on that board. Look at that light flashing. Let's head back to PyCharm and make some changes in our code. If we change the sleep time from 0.5 to 0.1, it's going to flash a lot faster. And why don't we change the print line so that it says CircuitPython in PyCharm is great. Since we just made a change, the little blue indicator for unsaved changes is back. I'm going to Command-S to save, Command-Tab to head over to the terminal. I see my code executes, takes a second, but it says CircuitPython is great, and my board is indeed flashing 5 times as fast. That was a lot of work to get things set up, but things are working. You're coding in PyCharm, you're watching the output in TO. Nice. Now, we did a lot of work, but importantly, now that our project is set up, you can actually regularly reuse this project to write new code. Nearly all the configuration is done. So to show you this, I'm going to quit out of PyCharm. You can do the same. I'll also quit the terminal with TO running in it. I'm going to restart my Mac. Now I've unplugged my board. I'm going to plug it back in again. If you want to save your code on your board before making changes, you might want to copy the code.py to your computer. It's probably good to store it in a Mac folder with a useful name so you can find it later on. Then open PyCharm, and we're seeing the last project, the CPB project, open with the code.py file open. Over here on the left-hand side, you can see the CircuitPy volume is mounted. That's the board we plugged in, and it loads up the code.py file that's on that board. And just in case this project window was closed, I'll do that now. Remember, we can select recent projects from this Welcome to PyCharm screen. I'll just click on the CPB CircuitPython project. That's the project I previously created. It loads up. Nice. Oh, I also spliced this bit in here to show you another point that I want to make. Since we have PyCharm saving our code.py file to our CircuitPy board, if you open the project folder, and for me it's on the desktop inside PyCharm projects, inside this CPB-CircuitPython folder, that's the name of our project, there's nothing in the folder. Now there actually is stuff in here, but it's hidden. The trick on the Mac to show hidden files is Shift-Command-, so we can see that there are some invisible folders in here. That's important configuration data that PyCharm is using in our project, but it's nothing we should click on to open. All this is managed from within PyCharm. There are also hidden files on our CircuitPy board, but we can ignore all these hidden files. So I'm going to Shift-Command- again. Since there's nothing to double click on to open our project up from the Finder, you always want to open your project up from inside PyCharm. Just wanted to make sure you all knew that. Now to get TO running, Command Space to open Spotlight, then enter Terminal, press Enter, and at the % prompt, if you type the up arrow key on your keyboard, we see the last command we'd entered. That was the command to launch TO. Press Return here, and we see TO runs, and we're connected to our board. Now, rather than type in a new program, I'm going to grab this short program from GitHub. You can find it at bit.ly/cpb-neopixels, all one word, all lowercase. This code runs on a Circuit Playground Bluefruit or Express, and it'll flash all the lights on and off in blue. Feel free to write your own code if you've got a different board, but I'll highlight all this code, copy it, Command-C, Command-Tab to get back to PyCharm, highlight this old code, paste over it with a Command-V, and there's my new code. And this is just like I wrote a new program using all the setup and configuration from our earlier project. Now notice we don't have any squiggly lines under our import statement. The project already has CircuitPython-stubs and Adafruit-CircuitPython-NeoPixel packages loaded up. But remember, if we were working with any new libraries, we were importing new libraries that we hadn't added to packages, we just go up to Settings, our project's Python interpreter, then press the plus icon, enter the name of our library, making sure that we modify it so that it's got the prefix Adafruit-CircuitPython-, select the library, click Install Package, and that'll be it. Now it looks like one configuration was lost when we quit and returned to this PyCharm project. The yellow squiggly lines under board dot and in all caps NeoPixel means that PyCharm doesn't remember that we had previously set the board to the Circuit Playground Bluefruit. Now that's not too tough to reset. Just click on the PyCharm terminal icon in the left-hand side. This is different from the Mac terminal. We want to use this one. Unfortunately, the up arrow trick doesn't work here. It looks like the PyCharm terminal is actually remembering commands from Mac terminal, but we definitely want to perform this command in the PyCharm terminal. So to remind you the command to set the board, it's just CircuitPython_setBoard, one word, space, and then the name of the board. Our board is named Circuit Playground_Bluefruit. Press Return. The board is set, and the yellow squigglies under the board dot all caps NeoPixel are gone. Nice. Now to execute this, notice we have changes to save. We can see the little blue dot next to the code.py tab. So when I type Command S, the changes are saved, the dot goes away. I'm going to Command Tab over to the terminal, and TO tells me that the code is running, and print CircuitPython on PyCharm is fantastic, and the CPB is flashing on and off as expected. This shows we can reuse our PyCharm project for new programs. There's minimal additional setup, but we're going to get all that great error handling and code completion of PyCharm, which you'll see as you code more is going to help prevent a lot of errors and typos that Moo or other editors wouldn't catch. By the way, if you run into any problems, every once in a while I've noticed that code might not run on TO. Just remember you can quit out of PyCharm and the terminal program, unplug and replug your board back in, then open up your project and terminal and run TO, and things should start working fine. So that was a longer lesson than our usual, but I think PyCharm will be a great help for your CircuitPython code. Keep hacking, there's a lot more goodness to come.